Okay, so you make new file here, fc bright bf12 decision tree. Okay, we close this and we make the outlines for this.
Make sure you if you're good at running away, run away. No.
Number one,
Okay, what I mean
import libraries. Number two, load dataset. Number three, preprocessing. Number four, data split, training, set, and validation. Set. Number five, training, decision tree, and then make the model. Number six, making prediction. And number seven, render the tree. And finally, utilize the model to predict new data. Okay, and then you can see also in the left side here, yeah. So make adjustment to your code accordingly.
yeah.
Okay, so we start with the import libraries. So here you import some libraries, Pandas, okay, Scikit-Learn tree, decision tree classifier, and then import also the tree, yeah. And then graphics, no need. So here from Scikit-Learn, you import a model selection, import trend test split, and then you also import the Scikit-Learn metric. Okay, job lib, no need. Okay, Scikit-Learn processing. So you need to import also Scikit-Learn processing, import LabelEncoder. Okay. And the you also need to import the Matplotlib. So import Matplotlib, pyplot, SPLT, and then the SNS. Okay, so for the metrics here, you import not accuracy score, but you import the confusion matrix, and then the accuracy, no need for now. Classification report. All right, so that's all the libraries that we need. So I already share you to the through the meeting chat, the data set. So you can copy paste the data set as a sample from here since you don't upload into the Google Drive in the CSV. Instead, we use the data set, the hard-coded one like this. So you can see the meeting chat or the WhatsApp that I send you the data here. You just copy paste in your data set here. And then data frame, you make variable and make object from data frame of the data, and then you can display. Okay, we can run from the import libraries. Okay, so everything is going correct here. Number one, and load data set. I run this. As we can see in the screen that we have the instance here, 13 instance, okay, 13 rows. Okay, so make sure first, after that, I will explain what is the data set about. So this data is about play golf. So we can see that we have the label here. So this label is the play golf, yes or no. Okay, so this is binary, yeah, binary label. So no, no, yes, 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 no, yes, no, yes, yes. So this data set tells about whether play golf or no. Based on attributes, the attributes is the day, sorry, not day, this is the object name, sorry. The attributes is the outlook, temperature, humidity, the wind. Okay, so we have 1, 2, 3, 4 attributes. So these 4 attributes will determine whether play golf or no. Okay, and this all the observe data. So day 1, day 2, day 3. Actually, we only have 13 data set here. Sorry, 13 instance. So it's supposed to be more, yeah, to have the model better. But this is this example only. So the thing is the 4 attributes, these 4 attributes will be used to decide whether play golf or no. Okay, so exactly attribute reflect. So this attribute reflect the condition of the day, the outlook, the temperature, the humidity, and the wind. So whether the outlook is sunny and the temperature is hot and humidity is high, the wind is weak. So based on experience, that play golf is no. So actually, people don't play golf if they found this kind of attribute with this value, yeah. But we are not sure whether because of the sunny there, then not play golf, or whether the temperature high, then not play golf. Maybe the combination of 2, combination of 3, or maybe more combination, more complex of 4 attributes. Okay, let's see here. The second, sunny, and then hot, high, and strong. So play golf if is no here. So wind, when we see wind, weak or strong, the label both this label both are no and no here. Okay, weak and strong. So is it the decision play golf? Is it based on the wind? I'm not sure. Maybe actually because the outlook is sunny and the temperature is too hot, maybe, yeah. Maybe. So let's go into number 3. Outlook is overcast. The temperature is hot also. So temperature is hot, humidity high, the wind is weak, but this one is play golf. So 1, 2, 3, actually temperature is hot. 1, 2, 3, humidity is high. Hot and high, but play golf sometimes yes, sometimes no. So reading this data, we are not sure which attribute that very strong influence, giving influence to decision whether play golf or no. Is it because the outlook overcast then play golf yes? I'm not sure as well. Or maybe because the wind is weak, play golf is yes. But here, number 1, wind is weak, but play golf is no. Okay, let's see number 4 here. Outlook is rain. Okay, temperature is mild. Humidity is high, wind is weak. But play golf, yes. Actually, outlook is rain, but play golf, yes. But number 5, outlook is rain, but play golf is no. Okay, so based on our observation, we can see that there is there is cannot be only one attribute that determine the decision. So this must be the combination of maybe between outlook and temperature, or maybe between outlook and humidity, temperature and humidity, or maybe the three among them, these three contribute to the decision. So this is the thing that we want to learn, and we're gonna build the model to learn the data, and the model, we're gonna have the model, and later on further we have a new data we input to the model, and the model will decide whether play golf or no. Okay. All right, I hope this explanation can bring a clearer understanding for you about the data, about our data. So we continue to the pre-processing. Um, let's see the information of our data here. So actually all of the attributes we have here and no missing value. All of the attribute in the type of the object here. Okay. And we continue here. You can type this, okay? And I continue with the next one. So I want to change the object or the string value to numerical. Why? Because remember, bear in mind that when you have the object, you cannot continue to process that in statistical way. So that's why you have to convert this into a numerical. Okay, so this numerical can be in the term of the integer or either in term of the integer or float. Okay, which one is okay. So this is the way of converting that object into the numerical. Okay, can continue with this. Yeah, follow my my code here. So LE, label encoder. Okay. So label encoder. Okay. We make object of the label encoder here. And we can have the DF outlook. So actually the Gemini suggests, because Gemini read this. This is the way that we are going to achieve here. So it can suggest something that very close to our objective there. So we take the DF data frame and we specifically certain attribute here, which is the outlook. So the outlook here, we do the fit transform. by using the fit transform from the label encoder, which is the property library already included here, label encoder. Let's go up a bit here, label encoder. So this one will be used for the transforming from the object into the numeric. Okay, so this is label encoder. We have the object. Now we do the fit transform and then suggestion automatically by the AI for the rest. So we have the temperature, humidity, wind, and also the last one is the play golf, which is the our target, our objective label. So that's it. This is the way of changing converting the type of object into the string. So finally here we can print, you can print the df, or also you can just df. And finally you're gonna have the same attributes, but the value now different. Yeah, this is 2, outlook is 2, and then temperature is 1. So how can the library automatically transform this outlook for the instance number 1 become 2? Okay, so let's see here. The outlook is, we focus on this, okay? So the outlook is 2201. Okay, let's go above a bit, go upper here. So actually 2 is indicate the sunny, and then overcast, and then rain, rain, rain. Okay, so when we see here that 2 is the sunny, or 0 is the for overcast. Okay, and then the next is rain. So rain here indicate by 1. Okay, so actually when we have this kind of the label encoder will look for all of the value that we have in our data set. Okay, so all of the value is in here, and then it takes the unique one. So all of the unique will be highlight here, which is the sunny, the unique, overcast is unique, rain is unique. So the rest is the rain, overcast, sunny. Okay, repeated the same one. So the algorithm will make a mapping. Maybe, yes, of course, sunny can be 0. This one can be 1 or 2. Yeah, maybe randomly it takes the value. This one is 0, 1, and 2, or whatever. But the thing here is it does the mapping from the unique value that it filter out. Okay, so the same also applied to these attributes. Yeah, so take the unique one, which is the hot, mild, and cool. Also this the 3 value, hot, mild, and cool. So that's why 1, 2, 3 will be for the temperature. Let's see, we are going lower here. 1, 2, 3 also for the temperature. We see if you see 1, 2, okay, 0, 1, 2, sorry, I corrected that. 0, 1, and 2 as for the temperature value. Yeah, so this is the purpose of the label encoder, transforming or converting from the object string into the numerical. Okay, and here you make a new code. Okay, and then you put remark on this. You split the attributes as computation parameters and as target label. Okay, so here you X, so actually will be suggested by the AI here. So X, which is the capital letter, yeah, X is taken from the data frame. Okay, but here I need a kind of little adjustment. So DF not drop lah, but the way that what will be included there. So this one is not the day, but the outlook. Outlook will be the attribute that we calculate for the to determine the to decide whether play golf or not. So the play golf here, I will move this to this below already there. So the Y is the target, the X is the attribute that influence our target. So this one is temperature, and this is the humidity, and also the wind. Okay, so I split them, okay, to have the variable for the parameter computation here and the variable for the target here. Okay, then you run. Outlook, temperature. Which one is wrong here? Humidity, outlook, temperature, humidity, outlook, temperature, humidity. Humidity and the wind. Yeah, because this is gonna be the list, yeah. So I have the double here, the square bracket. So it's nothing wrong with the name label attribute, but the way I'm using this must be of the list. Okay, so execute. And after splitting, you can see the result by typing X comma Y here, and you're gonna have the X is there, outlook, temperature, and wind, and the play golf, or maybe just type Y. Here also you can have the play golf. If you have X, you can have all of the variable there. Okay. So X actually all of the variable that will determine, that will be calculated to decide whether play golf or not. And Y is the play golf, yes or no. Okay, so you do X and Y. Okay, yeah. Okay, so based on this is the factor, the variable that influence. Ini ya. This is the variable that influence the target. Okay, the variable that influence the target. So that's why we call this as the independent variable. Okay. And we have the other one is variable that depend on the independent variable. So we call this the dependent variables. Nah, so the outlook, temperature, humidity. So this is the variable that will be calculated to determine play golf or no. So that's why this is the influence variable. All of the variable that give the value to decide whether play golf or no. So variable that influence the target. So this one is the variable that influence the target. Okay, so this is the variable that influence the target. And the target is this one, y, play golf. It's a variable that depend on the independent variables. That depend on the previous variables. So this is the target. Yeah. So remember the independent variable and the dependent variable. Okay. We also sometimes we call this as the target variable also can. Dependent variable or the target variable also can. Okay, so this is the target, this is the dependent. Why dependent? Because it depends on the independent variable. Okay, so now we continue to the data split here. Okay, so from the X that we have, okay, we do the X train, X test, Y train, Y test. From the train test split, this is the function that imported from the previous one with the random state. Okay, so you can just use this. Test size 0 point, random state is 42. Okay, and then we can see what is the X train here. Okay. Okay, so you make the splitting of the validation at training and validation. Okay, so you run, you have the X train is this. You run again, this is the X train. So when you see that the value keep the same value here. Yeah, whenever you run, the value is still the same. Okay, what happened if you change this become, let's say 1999. Yeah, you change a bit there. What happened when you change? Okay, so let's run. The value kind of different, yeah. Along the way of you rerun, the value can be different. If you have the, okay, yeah, the value different. Okay, so we normally use the random state 42 to keep the same value as the X train here. So every time we run the model, it will learn from the same value. Okay, adjust the code. Okay, so this test 0.2, it means that for the training, we use the 80% because 0.8. And for the test, we use 20%. So when we state here the test size is 0.2, yeah, this actually means that the test size is the 20%. And the rest will goes to the training, 80%. Okay, so that's why when you find, okay, you can calculate here that when we have the 13 rows times 80%, so this kind of maybe 11 rows that will be left for the training. Yeah, because 80%. So, okay, so we can count this, how many that we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so correct. This is the 80%. Number 5, we continue. And here we do a training decision tree. Okay, so we make a new classification. So decision tree classification. Just tap this. Yeah, okay. So far we don't have the criterion entropy. Just leave it blank and then fit the train and then the Y train. Okay, so this is the way of making the training. And we have the decision tree classifier. Okay, just the code. Okay, now we have the model. Yeah, so this is the model. We already make the model. This model was generated by learning from the data. Which data that it learn? It learns from this data, which is the 11 rows that we have previously. Okay, so it learns from them, from there, and then the model was generated. Okay, so let's make the prediction using this model. Still remember that we have 13 data, so we still have another 2 rows. Yeah, so these 2 rows will be predicted using the model. Okay, so we continue with that. Now we are making prediction here. So we use the Y prediction here, the CLF. Okay, this is our model, and then we predict. Okay, and then we can run. Okay, so after we do prediction, we can render the tree. Okay, using the PR plot here, plot figure with the size, determine your size, and then tree, plot tree, call the model, fill true, future name, column, and class name is no or yes, and then you do the show. Okay, so I ex expand this to full screen like this. Okay, and then you can run this. Nah, so this is the result of our tree. Okay, the result of our tree. Okay, I'm gonna explain you after you completing number 6 and number 7. Okay, so this is how you can interpret this. So actually at the top one here, we see that it comes with the outlook first. So if the outlook score is 0.5, okay, so it means that, yeah, I'm sorry, I have to make this bigger. One moment. Okay, so this should be just become 24 by 10. Yeah, to be more clearer. Okay, so this is much better. 24 times 10. Okay, or maybe I have 15 here. Better. Yeah, okay. Uh, okay, so it starts with the outlook. So actually outlook is the strongest influence. After outlook, win is the second strongest. Okay, so how we can read this? So the model learn from the outlook is very strong. Okay, so whenever the outlook is under 0.5, so it goes to the yes class. Yes, so play, just play uh, golf regardless of the rest of the variables. But if the outlook false, it means that not satisfy less than equal 0.5. Okay, we have to consider the next variable, which is the win. Okay, so how about the win? If the win 0.5, so the answer is the play golf is automatically become yes. But if this condition is not satisfied, it will consider to the other one, which is the, wait, uh, okay, should be the humidity. Where's the humidity here? Okay, one moment. Let's try that again from this train, okay. And then we do training. Make sure that you have the 42 here. Okay, and then we do the training. And then we make prediction. Okay, and then you do the 3. Nah, this is much better. Okay, so from the outlook, after the outlook, it will be look up for the humidity. Okay. Now, from the humidity, here, it will check the outlook again. Whether the outlook is less than 0.5 or the outlook, this one also 0.5 at 1.5. Okay, but when we see here, that this is a kind of like repeated, yeah. So let's see here, the outlook 0.5. If this satisfy, then go to the class yes. Okay, but the outlook is greater than this, it will check the humidity. And from the humidity, if humidity is 0.5, then it goes to this one. Check again whether the outlook is 0.1, 1.6. If yes, then go to this, check the wind. If no, go to this. Okay, so it's kind of like double checking the outlook, back checking again. Yeah. Now, from this, if the outlook greater than 0.5, so yes, class here is yes, play. But if no, check the win. Okay, if the win is less than 0.5, this one is play. Okay, a play no. And otherwise, play yes. So it's kind of like repeated checking from the previous variable. So cannot be after one variable become the second variable. No. So when we see here once again, we see the outlook. Okay. So we see the outlook and then we see the humidity. If the outlook here not satisfied, we see the humidity. But after the humidity check, we see again whether the humidity satisfied or not. If satisfied, then check the outlook again whether satisfy this. Okay. If yes, check the win. If no, you just say the class is not don't play. So the same also go to the right. Okay, so this is the way of deciding whether play the golf or no by using the decision tree. Okay, so this is the last part. How we can predict a new data. Okay, so this one, predict new data. So let's say we have the new data here as the data frame with the outlook. Let's say we have the I'm sorry, here it should be the overcast. Okay, are we going to play the tennis, to play the golf or no, based on this? So temperature is the cool, and the outlook is overcast. Okay, and then I have to close this first. Okay, yeah, we make kind of the dictionary here. Humidity is high and wind not weak, but this one is strong. Okay, so if we have this kind of a weather condition, are we going to play golf or not? When outlook is overcast, temperature is cool, and the humidity is high, and the wind is strong. Okay, what should we decide based on this? Okay, don't forget to put comma for each of the. Okay, so after that, we make the label encoder of the outlook. Yeah. So here we do the label encoder of the fit transform. Okay. Label encoder fit transform of the here of the data here. The data of the outlook. Okay. And time also. Okay, temperature, humidity.
Kak Ivan,
Yes,
aku harus lift awal ya.
nggak apa-apa, boleh.
Terima kasih, Kak.
Oke, target. Oke, that's it. Nah, ya, for the width, for the target is the play golf. Oke, this way ya. Label encoder, and then fit, not fit transform, sorry. This is the fit, just fit. Nah, fit the data of the outlook. Okay. And then we apply to the new data here. When the new data that we have, we apply all of the outlook, temperature, humidity, and wind with the transform of the new data outlook here. Okay, so actually this is the recreate encoders per column using training data. Okay, in here you apply the encoders to the new data. Okay, and here you make prediction. And in here you decode the result. Okay, and then display. Okay, so this is the step of our inference. Okay, this is step 1. You can adjust. This is step 2. This is step 3. And this is step 4. Step 4 not yet. And this is step 5. And this is step 6. Okay, so you can adjust this code. Okay, now we make the prediction here. The new data here, the prediction encoded. So we take the model and then we do predict using the new data. Okay, because it's only one content, so we take the first element. Okay. And then the step 5 here, the prediction is the target in first. This one, okay. So this is the target. Take the target. We inverse transform prediction encoded. This. Okay. And then we print the result. This bring down here. Okay, so prediction for new input is the prediction. Okay. And so here we have the target as the play golf. Sorry, this is play golf. Something not proper. So check all of the variable name: temperature, humidity, wind, and play golf. This is the target that we have. Okay, so the target will be used to do the inverse transform of the prediction encoded. Okay, so let's run. Wow, something wrong here. Prediction for the prediction. Comma. Oh yeah, this one is print F should be here. So the prediction for the data is the yes. Yeah, if you say for the input here, or maybe you can call the new data again. Nah, yeah. Prediction for new input, temperature, humidity. Okay lah, no need lah. So better this way. Now, so the prediction is yes. When we have the new data, we have the outlook forecast, temperature cool, humidity high, and wind strong. And when we predict based on the model that we have, the result is yes. Okay. So that's all. This is the end of our decision tree. So based on this, we can actually we have the data here. Okay, and then we make the model and we do the prediction. So the data will generate the model. So actually the model, the ability of the model is basically based on how many data that it learns. So the more the data that the model learn, it means that the more sophisticated, the more the ability that the model has to predict. Okay, this is the end of our decision tree.